Hi, Professor. We can't hear you.
You can hear it?
Yeah, your audio's off.
Can you hear me now? Yes. Okay, great. Thank you. Awesome. All right. Every week we're slowly making progress back to some reasonable hardware situation. Great. Okay. Thank you. Awesome. Great. Okay. So let me get back to the hellos. So hello, Christopher. Thank you for that. Hello, Michelle. Thank you for that. Hello, Cheska. Hello, Avani. Hello, Amanda. Awesome. We've got a high percentage of video today. That's awesome. Hello. Hopefully you guys are also seeing that now. I'm still catching up with myself and with you, but hopefully those of you who have been submitting, oh, and there's someone else. Oh, a lot of people. Hello, how are you? Awesome. Those of you who have been submitting for various kind of points, like video or using the YouTube channel, hopefully you're seeing that you are getting, I mean, I had fallen behind, but you are getting those points. I hope you see. But anyway, so great. I appreciate how many people really do show video and talk and all that stuff. Who else? So hello. So that's hello. So now people were saying hello in the chat. Yes. So good afternoon, Yavi. Thank you. Good afternoon, Melita. Good afternoon, Matthew. Good afternoon, Hayu. Good afternoon, Freddie. Good afternoon, Avani. And thank you, Hayu. Okay. So thank you all for being here and for the input, the feedback. Okay. We're going to get again. So one thing I think you know is you have a little break now. Like you've been ahead of me. You've been working hard to try to figure things out before I even explain them. We're all aware of that, I think. So, and we've got this big homework 4 that is a lot to talk about. And we know, I haven't even talked about homework 2 or 3 yet. Therefore, again, for this coming Monday, I'm not asking you to do any new work. If you are behind on anything, or if you had needed more time to try to figure things out, and you needed to wait till these lectures, then I understand. Then what you have this weekend is catch-up time. Please do. Wherever please catch up. Do your best. Same thing with me. But there's no new assignment for Monday. That also means, again, I'm just doing bookkeeping things here before we get into the physics. That also means that if you did make the valiant attempt to turn in homework 4 for today, like technically it was due today, right? I mean, again, parts of it were hard, parts of it were new, all of that. But if you made an attempt and you turned it in, then out of this 45-point assignment, then what you've already gotten, as long as you did something vaguely responsible, then you've already gotten something like around 36 points. Again, let me just remind you that you're doing drafts and revisions and getting more and more points, and I do drafts and revisions on the points. That is, yours was a first draft, your score is a first draft score. If you got something like a 36, let me just to remind you again how I work. That is an acknowledgement that you are on top of the material, that I know that you know that you've been turning in your work, that you're on time, that you're trying. That's 36 out of the 45 points so far. That's all it means. And you can test, especially if you look at it and you're like, wait, but there's not even feedback. So what did I do wrong? You didn't do anything wrong as far as we know yet. You don't owe me anything if you've already gotten a 36. It's now my turn to look at it more closely and see about the remaining 9 points, whether there is something you need to improve or not. But if you got like a 36 or something, then just congratulate yourself and wait for more feedback. Don't think it means that you owe me. It means I owe you. It doesn't mean you owe me anything, okay? I hope I know it's a funny system, but I hope that's clear. Also, again, it means if you didn't turn it in yet, you still can, you still should. You don't have any points yet. You'll get them when you turn it in, blah, blah, blah. Okay, I'm just looking in the chat. Okay. So there's no new work due Monday. If you have tried every assignment so far, you can chill a little bit. The one thing might be to watch a certain video, which I'll address in a moment. Okay, so I still need to catch up with you guys. Okay, now what we're gonna do. Yeah. Here's what's gonna happen now. This is slightly unusual too, especially because I'm not assigning any new work for Monday. Okay, I'm gonna say something slightly complicated now. And again, of course, I always talk too fast and say too little. So you stop me at any time if I'm unclear or if you have a question about something else. Like it won't be an interruption. What I'm going to say is this: we still have to go over homework 2 and 3. I'm very aware of that. 3 is like a left turn. It's like an unusual assignment. I'm aware of that as well. My main priority is to next go over 2. And that's what I'm going to do. Okay, in a minute, I'm going to start, and I'm going to jump to the hardest questions in homework 2 in a moment. I'm going to go over homework 2 in a moment, but I want to make clear. Well, in fact, let me make that clear. Hold on. So, okay, bear with me for a second. Hold on, bear with me for a second. What we're going to do in a second, we're going to go over the hardest questions, what I consider to be the hardest questions of homework 2. But I want to warn you, see, this is what I want to warn you of. We are going to go over homework, I believe, called average speed. What I'm probably going to do is just like say what the answers are to the sort of simpler questions, the exercises, the practice ones, and then I'm going to talk a lot about the last ones. But what I want you to know is in the other class this morning, right before I was about to start homework 2, some people in there were very concerned about homework 4 because, as I warned you, it really was a big leap. I think not an impossible leap, and I think not an unfair leap, but a big leap from where we were. So in the other class, they asked me to just skip they sort of encouraged me to just skip ahead and lay out all the concepts that they needed for homework 4. Some people who had turned it in but felt really rocky about it really wanted to know what was going on with it. And some people had not turned it in yet. So I want you to know that in the other class this morning, I just went straight to the big concepts for homework 4. And I didn't say anything about homework 2 or 3. The reason I'm telling you that is that I want you to be aware, because now very deliberately in your class, I'm going to explicitly go through the hard stuff of homework 2. What I want you to do for Monday, as I said, is no new homework, but I want you deliberately to make a point this week to watch the video from the other class. I will post it in your classroom, but it's already on YouTube, So in a second, I'm going to clarify that because you're going to watch the other class video and they're going to watch yours. And that will okay. And that way, between the two, we'll really start catching up with ourselves. Okay, so I will clarify Google Class, but your one homework that I do want you to do for Monday is watch the other class video. Can I just get confirmation that that's clear what I'm saying? Like, thank you, Michelle. Okay, thank you, Hayu. Thank you, Amanda. Okay, so I'm saying you are responsible for that material, and I'm not necessarily going to do any more lecture on it besides it. So, okay, you get yes, that's clear. Okay, thank you, Melita. Okay, great. So that said, and those of you, especially if you haven't started homework 4 or you're having trouble with it, then definitely watch I think the other video will help. Anyway, whenever you get it. Okay. So now let's talk about homework 2. We're going to go to homework 2 here. Bear with me for a second because I have to pull up the other window or the screen. Sorry. Okay. Bear with me. As I'm getting ready to do this, a clarification also, notice we're making a big point about average velocity in the class. The big issue really in the class that we need to ultimately understand is displacement and velocity. And what we have equations for and everything is these vector quantities that do care about direction, such as displacement and velocity. Note that this sheet, homework 2 that I'm about to go over, it's only really concerned with average speed. And that's not an accident. It's not a typo. It's not concerned with the direction. The reason for that, just so you know. So in that sense, maybe it's like a little bit easier to deal with. It's also a little harder because maybe like equations aren't as obvious. The main thing in this sheet is it's really trying to emphasize what it means that we're talking about average. So it's trying intentionally to not get too bogged down or too worried about the direction. But anything I'm about to say in going over the sheet applies also to the concept of average velocity, okay? Every single big concept and every equation that I write down, it all also applies to velocity. It's just that in this sheet, we're not worried about different directions. So basically, another way to put it, you might want to say in your notes is, as long as something's always traveling in the same direction, then there's no distinction between speed and velocity. Then like the distinction doesn't matter. It's only when things turn around that they really start to matter. Okay, that said, the average speed, okay. All right, first, so I'm doing the average speed sheet. Hopefully you have it in front of you. And the whole key point of the whole thing is that average, the only thing we know for the whole thing is that average speed equals distance over time. If we were thinking more rigorously, more precisely, what we really know for this is that average velocity equals displacement over time. Like if you're thinking in terms of equations, the one equation we have for this whole sheet is that one, okay? So first I'm going to do the warm-ups. The warm-ups are warm-ups. They're meant for, so I'm not going to do the whole 5-step method. I'm basically just going to write down what I think the answers are. If you don't like my answers, you should not. I mean, if you don't understand or don't agree, please do put something in the chat. I'm going fast just in case I can, but if you have an issue with any of the first 3 warm-ups, you should let me know. But I'm going to assume. So the first one is a new car travels a total of 60 miles. The trip takes 2 hours. What's the car's average speed for the trip? I think the car's average speed for the trip is 60 miles over 2 hours, i.e. 30 miles per hour. Like that's what I think the answer is. Boom. Like again, these are answers. Like if you just wrote that in an exam, that would not be good enough. Okay, these are answers. Okay, so I think it's 30 miles per hour. We're just going to check. If you have an issue, please let me know. Looks like you don't. Okay, but quick sidebar on that too. Like, what does that mean? Just to remind you, if I say a car travels 60 miles, it takes 2 hours. And you might want to write this in note. If I say the average speed is 30 miles per hour, and like, yes, all I did was divide 60 by 2. But what does it mean that I'm saying? It means 2 things. One thing, and again, please, maybe if you are trying to stay awake today, maybe write these 2 things down. But in terms of what this means, it means number 1, that car accomplished the exact same thing as a car that went a constant speed of 30 miles per hour for 2 hours. Okay, literally to say that this car's average is 30 means that it accomplished the same thing, or it got as far as any car that did go constantly at 30 miles per hour for those 2 hours. But the second thing it means is we don't know for a fact that this car did go 30 miles per hour constantly. Okay, please understand that. The whole issue of an average is it's the one number that we could use to pretend or to create the equivalent of constancy. If we say this car's average is 30 miles per hour, we're not saying it was always going 30. It literally, truly might not have been. It might have been going 90 sometimes, and it might have been parked sometimes. We have no idea how fast this car was going at any given moment. But we just know that at the end of the day, how far it went was as far as a car that did, in fact, go constantly for 30 miles per hour for 2 hours. Okay, that's what it means. That's what an average means. I'm just looking to see if there's any question about that. It looks like there aren't. Okay, I'm going to go on. So that's the answer to that one. So then, hello. An old car travels a total of 40 yards. This trip takes 4 days and includes 3 breakdowns, i.e. it stops 3 times. What's the car's average speed for this trip? The average speed here is again just 40 yards per 4 days, 10 yards per day. That's the answer. Okay. Yes, it is just a plug and chug. I mean, it is just a plug and chug. What am I trying to get at with these warm-ups of these exercises? Well, yes, they're warm-ups, they're exercises. But also, I'm trying to emphasize, notice this. Our definition covers the whole span of questions. Like, even though this car stopped a couple of times, even though it was going 0, doesn't matter. Still just works. We don't have to separately count that number in the average. The average is the total distance divided by the total time. Second of all, notice maybe we prefer some units to others in a science class, but all units are acceptable as long as they're consistent and as long as we have units, right? So average speed could be measured in yards per day or yards per minute or meters per second. Like, okay, there might be preferences, but it's all average speed regardless, as long as it's distance units per time units, then it's average speed. Okay, then finally C, and these are realistic numbers. C is just another little practice, a reminder that as long as you have this one equation, you can and should rearrange it to solve for whatever you want at any time. Like this question, I know we did this last time in number line, but this question doesn't ask for an average speed. It asks for a distance. You don't want to be thinking, and I know most of you are not, but you don't want to be thinking, well, we don't have a formula for distance. Did he ever give us a separate equation for distance? No, you just rearrange what you have. In other words, if average speed equals distance over time, I mean, you know where I'm going with this. If average speed equals distance over time, then distance equals average speed times time. And you know, and really quick side note, if there's one equation you've probably known since 3rd grade or probably heard people say since 3rd grade, it's distance equals rate times time, right? That you notice we never literally say that in a physics class. In a way, all of physics is an expansion of that idea. In a way, all of physics is kind of an expansion of that idea, but we never literally say distance equals rate times time, because as you're seeing now in physics, that's way too ambiguous. That is way too imprecise. Like it's not true. Like there's all different kinds of rates in physics. There's rate of average speed. There's rate of average velocity. There's rate of average acceleration. There's rate of instantaneous speed and instantaneous velocity. Distance equals the rate called average speed times time. If you want to memorize anything from 3rd grade, don't memorize distance equals rate times time. It just isn't true. Distance does not equal rate of acceleration times time. What distance equals is average speed times time. That's what they mean when they say that in 3rd grade. So in this case, the average speed of light, and this is a true fact, by the way, light does travel 186,000 miles per second. That's very fast. So in 1,000 seconds, we can, just use scientific notation or whatever. We can say that light in 1,000 seconds will travel. We just move the decimal point 3 spaces and say that it travels 1.86 times 10 to the 8th. Or in other words, 186 million miles is how fast light travels in 1,000 seconds. 1,000 seconds is about 20 minutes. So in 20 minutes, light travels about 186 million miles. That's true. That's very far. Okay, so that's it for the warm-ups. Let me just check the chat to see if you're okay. So is everybody okay? Should I move on to the hard thing now? Are we honestly, can I get like, thank you, Christopher. All right, it works for me. Thank you. I love this feedback. I think I gotta make a portal for like human thumbs up. Okay, but all right, so we're going on. Oh, now we're at. This is a real problem. I don't care who you are. I mean, some of us got this right. Some of us got this wrong. A lot of us got this wrong. Classically, a lot of people do get this wrong. No shame. Even those of us who got it right, who should feel very proud of themselves, I think there's still a lot for me to say about it, and it's like always, if you got it right, don't take this as an opportunity to tune out. Take it as an opportunity to pat yourself on the back and to relax, knowing you're not stressed about the answer. So then you can, like, in a relaxing fashion, absorb what any other perspective that I might have to offer on what your thinking was. I think this is a worthy classic problem. Oh, and the other key behind those warm-ups was to really reinforce all we know for this whole sheet is the definition of average speed. Therefore, that's all we can be expected to use. Somehow or other, that definition has got to get us through this whole sheet. That's like important for this question. So what do we have? I'm going to do a little 5-step method now because this problem's more involved. So step one, fact pattern. Right now, here's an example. Like, no one gave me a picture here, but if I'm doing problems, I have to, like, step one is provide diagram and fact pattern. So I've got to provide it now, so I'm not copying anything. I'm like literally providing it. I'm sorry. Yeah. So there's my diagram, right? Just a picture of the facts. And those are all facts that were given. Now I'm going to start dealing with this one like with equations and stuff. So in fact, let me do one.
Professor, I have a question.
Oh yeah, hold on. Yeah, 1 second. Sorry. Great. Hold on. We'll explain those symbols in a second. But yes, Christopher. Yes.
Yeah, in the question, right? Doesn't it say she turns around and drives downhill?
Well, yeah. Okay. So I'm in my absolutely, and so maybe my picture is okay. So I have She turns her. Yeah. Okay, wait, let me switch the screen here. No, you're right. So, okay, so I could, maybe this is a better drawing then. All right, I see what you're saying. I think it comes to the same. So we could do it like, it's easier for me to draw it the way I just did it, but sure, we could go like this. The better picture. You're right. I don't mean, you're right. Hold on. better to draw like this? Is this what you're saying, Christopher, and someone else? Yeah, okay. So no, and that's totally fair. I don't mean to dismiss that. He's totally right. And I think someone else said same thing. I don't know if it was you or someone agreed with him. And you're right. The way the problem's presented is like you go up this hill and then you come back down the same hill. I probably should have just drawn it that way as I now have. In my mind, it was just easier to think of it as up a hill and then down the other side of the hill. But you're absolutely right. And yes, it does use the word turn around. One odd thing, and this is a funny thing about reading physics problems that takes some getting used to. What I think Christopher and someone else, and you could tell me, I don't know who it was. I think maybe it was you, but I think Christopher is concerned because the problem actually goes to pains to talk about turning around. So Christopher very legitimately is like, dude, you like went to the effort of saying turn around. So I assume that meant something. Like I assume it was significant. So can you not put turn around in your picture? Like, what are you doing, About fair point. Like I did go to pains to say something about turning around. Now, the odd thing is why I went to pains to saying something about turning around was actually to make it clear that the whole sentence that when it went to turning around, it takes a negligible amount of time. So what I'm trying to emphasize there is that the whole reason of bringing up the turnaround. And so maybe next time I should write the problem. Maybe I should just say he falls back. He falls on the other side of the hill or something. But really what the problem is trying to get at is that turnaround is so short that nobody should get bogged down in taking it into account in their calculations. Like this is a weird thing in physics is sometimes we're acknowledging some kind of piece of reality in order to specifically say to you, you don't have to worry about that reality too much. But of course, by pointing it out, in some ways, we're confusing everybody and we're like drawing more attention to it than necessary. We're trying to say here that the whole journey that we're concerned with is up and down. And yeah, the car had to turn around or something like that, but it took so little time that it's not going to affect the rest of the calculations. That's what we're trying to say. And if anybody's thinking like, well, that's really unrealistic. And I think it's great that Christopher and someone else brought this up, like, because all these kind of issues used to really get me in physics, and they get a lot of people. When we say the turnaround time takes a negligible amount of time, meaning an amount of time so small that you can neglect it, you can ignore it, for sure, there's got to be some people in the room. I was one of these people who I used to think, oh, for God's sake, that is so unrealistic. I would think to myself, I could almost understand that if it was just like a math problem, or a philosophy problem. But like, isn't this supposed to be science? If this is science, why do you physics people like constantly say things like, oh, it takes a negligible amount of time? Or physics people are always saying things like, oh, the friction is so, oh, my board just disappeared. Okay, I got it back in a second. Physics people are always saying like, oh, the friction is so small, you can neglect it, you can ignore it. And of course, if you're thinking like, well, that does not sound like science. That sounds like BS. That sounds like Smurf Village. That's fair. That's a fair thing to be concerned about, but there's an answer. There's a deep, deep answer to that. The thing is, this is science. And again, I'm just taking the opportunity to address this larger question because I think it's a good one, and then I'll get back to it. Because this is science, and it's not just fiction in our head, the ultimate reason we believe anything we ever say, the ultimate arbiter of truth in science is measurement, right? We ultimately, if this is like a realistic problem, the numbers didn't come out of our heads. The numbers came from measuring instruments like stopwatches and rulers and whatnot, right? And therefore, if the only reason we ever believe numbers is if they came from measuring equipment, when we say something's negligible, what we really mean is it's there, sure, but it's too small to register. It's too small to measure. And you'll see that in the other lecture that's being recorded. Very important point for calculus. When we say something is negligible, or we say in the limit as something approaches zero, hello calculus, if we say in the limit as something approaches zero, or we say negligible, or we say infinitely small, the weird thing is, the reason we can get away with that is precisely because we're scientists. Because what we're saying in a situation like this, and then I will move on, I promise. What we're really saying is, imagine this hill is so long, like we deliberately set up an experiment where the car takes so long to get up and so long to get down that even though it might take like 30 seconds to turn around, it's taking hours and hours to get down. So all the clocks that we use only register hours and minutes, and they can't even pick up seconds on the clock. That's what we're honestly saying. We're saying when we say that one thing is too small to be, so small to be neglected, or if we say that something is in the limit as t approaches 0, what we're really saying is everything else in the experiment is so big that our clocks or our rulers can't pick up that number. It's there, so it met, but it's too small to put a number to. Okay, so that's like an important thing, like kind of for the other homework on the other video you're going to watch when we get into but anyway, so yeah, but Chris was right nonetheless. So I should have had a turnaround. So now we're going to say the guy goes, and I'm going to put my board back. The guy goes up a hill at 40 miles per hour. Then he turns around super quickly, so we don't, just like really quickly, we don't register it on our stopwatches. Then he comes down, or she comes down at 60 miles per hour. And the last thing that we absolutely do know that Chris's and other people's questions reinforces is what we know is that that distance up is the same as that distance down. And then my second diagram hopefully makes that more clear. What we don't know that throws a lot of people off, what we don't know is what is that distance. We definitively, and that's why I did not label it in the diagram. I'm coming back. Is it coming back? It's coming back. So here's the diagram back. Hello, there it is. Okay, I'll even erase. And if we don't like the first diagram, I'll just erase it. Yeah, it's not good. I think that correction was very helpful. And last thing I'm going to say, and I'm going to. So this is all the information I can put in my diagram. Up at an average of 40. At an average, excuse me, at an average of 40, and down at an average of 60. Also, please, last note, I put double absolute value symbols around the average velocities because I am trying to emphasize, like, when we're going to use these equations, the equations are really are for velocity and stuff. But I'm trying to emphasize here, I don't care about when one is technical. So one of these numbers would technically be positive and the other would technically be negative, but the question's not asking me to concern myself with that. So I'm just saying the absolute value of one is 40 and the absolute value of the other is 60. And those are the only facts we know. Distance, and I'm going to write then, distance up equals distance down. Like, that's a fact, but I don't know what that distance is. So this is my diagram and fact pattern. These are all the knowns of the situation. So now I'm turning the page. I'm doing step. And so step 2, what is the question? The question is, sorry, I'm looking at the chat. I just see this thing. That is dope. Okay, wait, I'm talking about X. Oh, wait. Okay, I see the thing in the chat. Let me get to the chat. I see 2 things in the chat. Let me get to the chat in 1 second. Let me just, since I'm still on step 2, technically, I'm gonna write the step 2 and then so step 2 is. Draft the chat, but that's my step 2. Well, that's my step 2. The question is, for the entire round trip, what is the average speed, right? And I'm saying, in other words, what's like the magnitude? What's the absolute value of the average velocity? Right? So I'm going to answer the things in the chat. Well, one of the things in the chat is like, then what's step 3? What do we write for the GDP? Right, for the GDP, for general definitions or principles, we only have one so far. We only have one. So yeah, that's what I'm going to write for the GDP. Absolutely, the GDP, the general definition or principle is that. But now let me answer the other question in the chat. So what does that mean? So all I know is that average velocity equals displacement over time, change in position over time. And therefore, I think average speed, in other words, the absolute value of average velocity equals the absolute value of displacement over time. In other words, average speed equals distance over time. That's what I'm writing down for the GDP. Now, but Christopher's other question in the chat, also a very good question, but slightly tricky now. Like X, I believe I understand the question. Like the X and the X naught in the numerator of this GDP, of this definition, those, like X minus X naught means displacement. It means how far you got from one position to the other. From one position to the other. Displacement is an interval between 2 points. The thing that I don't know, when I say that the distance up equals the distance down, I mean the distance, like the interval between the bottom of the hill and the top of the hill is the same as the interval between the top of the hill and the bottom of the hill. In other words, X and X, in the equation, X and X naught mean particular places. The difference between them is the whole distance. I don't know anything. So basically what I'm saying is distance up and distance down. I mean, to be honest, what I'm saying is distance up is not X and distance down is not X naught. Like X minus X naught. Well, maybe you'll see when I start doing the math here, but X minus X naught for a given interval is the whole distance. This may be more clear when I start doing it, but and someone's here. Sorry, I don't know. Maybe I'm saying to Christopher, it's a good question, but he might even want. I probably haven't answered it really yet. Maybe you'll see as I start doing this.
Oh, can I explain what I meant?
Oh, yeah. Sorry, yeah, absolutely.
No, because you mentioned like the integral stuff, right? So in class we learned that like you on the integral you picked a sub level, right? Or like a sub interval, and you say, okay, from xi minus 1 to xi, and you like find that average to approximate.
Wait. Say that. Okay, say that again. Sorry, say that again.
Okay, yeah. So like our professor was telling us how like on the interval, right? That like you can pick two, like you split it up, right? And then one of them could be like xi minus 1, and one can be xi on the integral. And you're approximating for that like rectangle in it.
Yeah, that's all true. I love that. And I love that you're relating this to calculus. That's good. But there might be a slight confusion here that the word and yes, we're getting into calculus for sure. And for sure, the other recording of this class gets into calculus. But what it gets into in the other recording is derivatives. The word I keep using, I have not yet used the word integral. Like you're talking about integral, but the word I'm using is interval. Like I'm just talking about like the interval, the segment, the space between two spots. I mean, yes, this all ultimately relates to derivatives and integrals and stuff, but I'm not yet actually saying anything about like calculus integrals. I'm just talking about when I say x minus x naught, I literally mean the difference between like if you were on a number line, if x naught is where you started, like position number 4, and x is where you ended up, like position -5, then the interval between the two is what we would call displacement. Like the different, like you started at +4, but you ended up all the way at -5. So your total displacement is that you got displaced -9 meters. Like that's all I mean. That's what I mean by like the numerator of this equation. I don't know. Does that address?
Oh, I get it now.
Oh yeah.
Yeah, I get it now.
Oh, cool. Okay, cool. But great question. Okay, cool. A great question. And I'm glad you're asking questions. Okay, cool. So All right, so I'm going to go on with this problem now. What I want to do is go to step 4. I am going to go to step 4, but I want to caution people right now. Notice, I mean, again, all these questions are good. Notice my GDP that I wrote down is so far in this class the only possible thing I could have written down, which is the thing I just circled. Average velocity equals displacement over time. Or if you wanted to write it in English, we would write average speed equals distance over time. But notice that I did, well, maybe I should just keep going, but what I did not write, I didn't write anything like average speed equals one speed plus the other speed divided by 2. Like, that's not a GDP. No one ever said that that was the case, right? So if I go to, even though secretly, the reason I'm saying that is I think a lot of people kind of, if you think the answer to this question is 50, again, no shame, but you want to be listening very closely to what I'm saying. Anybody who got 50 for this question somehow at some point took 40, added it to 60, and divided by 2 and got 50. But what GDP were they using to do that? Like, when did we ever say that? And I'm not being critical, but like, so if they did that, that means they either made up a GDP. Oh, hi. Okay, hello. Okay, teaching. Hi, good to see you. Okay, easy. Okay, easy. Okay, hello. Okay, in the middle of class. Okay, good to see you. I'm gonna take you to horses. Okay, good to see you. Thank you.
Hi.
Okay. So it means so anybody who added 40 to, and again, this is not a criticism, but you do need to take this seriously because everybody does this. If anybody took 40 and added it to 60 and divided by 2, that either means that they made up a GDP, like they made up a rule that we've never established, or made up a definition that we've never established, right? Or they violated the definition that we do have, or more likely, what it really means is they kind of skipped over step 3. Like maybe they even did write down what I'm doing, but then they just started doing something completely different. I'm just here to say this is the importance of the 5-step method. Like if you really take it seriously, it keeps you on course and forces you to not make up physics that isn't physics. Like, so I'm going to do this step 3. I'm saying the only GDP I have is that average speed equals distance over time, or average velocity equals displacement over time. Now, if I go to step 4, if I go, by the way, he doesn't really talk like that. I just want you to know. I mean, right now he thinks he's Ralph Wiggum, Chief Wiggum's son from The Simpsons. It's embarrassing enough that this happens, but he is actually normal sometimes. Not that there's anything such thing as normal in my family, but just so you know. Anyway, and good luck if you ever are in a Pokemon TCG battle against it. Like, just good luck to everybody. That's all I'm saying. Okay. What I'm saying now is if we go to step 4, W, i.e. particular application in work, right? If we go to step 4 now, what we might go something like this. Okay, we're looking for the average speed. Okay. Well, okay. We would start plugging in values, we would think, right? And the way I usually signal that I'm starting to plug in, or facts of this original problem, of this particular problem, I usually signal that by using the word here. Like I say here, meaning, okay, now here in this situation, right here, I'm going to want to know like distance and time to plug in. But here, distance up, well, sorry, I'll make this clear. Here, total distance that we're talking about must equal distance up plus distance down, right? I mean, I think that's fair. Like if average speed is distance over time, or if average velocity is displacement, the total distance here will be all the way up plus all the way down, right? And total time will be time up plus time down. Now I'm going to go a step further and say, so maybe we can make some notation to make our life a little bit easier now. Like, I'll say, in other words, saying like, so back to Chris's kind of thing, by x minus x naught, by the total distance, x minus x naught, what I really mean is x up, let's say, plus x down. Okay, that's in this context. Like, that's not a formula to memorize. That is not a GDP, but in this context, the total distance would be the distance up plus the distance down, right? And the total time in this context would be the time up plus the time down. So now I'm making up symbols for the facts of this problem, right? Okay, so I'm proceeding. Now I do hit a moment where I say, but here, x up is unknown and x down is unknown. Granted, what we do know is x, maybe I should have written this in. Well, no, let me write it the other way. Sorry, this is correct, but I'm just writing in the other order. Give me a second. Here, what we know, the one fact we were given is that x up most definitely equals x down. We know that, and the picture that you guys made me rearrange like reinforces that. We know as an important fact that x up equals x down, but we don't know what x up is, and we don't know what x down is, and we don't know what time up is, and we don't know what time down is. The reason I'm making a big deal of this is why this is a tricky problem. This right here, now this doesn't mean I'm wrong. I'm not doing anything wrong, and I am going to get an answer. But if you're doing it out in the 5-step method, right at this moment, you realize, oh, this is what's challenging about this problem. I need x up somehow, or x down, or somehow I need to do something with them, but I don't have them. So I have to think more in this direction. What I want to tell a lot of you is that the reason a lot of people made up a GDP that doesn't exist or skipped step 3 is what happens to all of us when we're panicked or nervous on exams or whatever. What a lot of you unconsciously or half consciously saw to the future, and you saw right from the start that you didn't have a distance. So you threw out, I shouldn't say you, I don't know if anybody, this is what I did the first time I ever saw this problem. Like literally, I looked at the problem and I was like, well, I guess it's 40 plus 60 divided by 2 is 50. Even though that's like not, like, why would I do that? Like, that's completely not an equation or a definition. But the reason I did that is because my mind so quickly saw that I don't have a distance and I don't have a time. So my mind was like, well, even though average speed equals distance over time, even though that's supposedly the only thing I know, that can't be right because I don't have a distance or a time. So I throw that out in my mind and then I start making crap up. You see, right? But no, we can't make crap up. What we have to do is write down in other words, to do that is to try to be relevant first and then try to make it true. And that's what all of us do when we panic. We try to think of something relevant and then we contort it until we think it's true. That's not the way to do physics. The way to do physics is to write down something that's true, even if you don't think it's helpful. Like we write down average speed equals distance over time. Even if somewhere in our brain we think we don't know the distance, it doesn't matter. It's still true that average speed equals distance over time. Then we start in step 4, start breaking it down and being careful and clear. So now I get to this point in step 4 where I'm like, oh, all right, I don't have the distance up. I don't have the distance up. That's kind of a bummer. That doesn't mean my equation's wrong. It means I have to do more thinking. What can I do? I can do this. I can say, well, my GDP, I still know that average velocity equals displacement over time, right? So isn't it true? Isn't it true that so the distance up must equal, I'm sorry, hold on, sorry. So if the distance up is called distance up, x up, right? And the distance down is called distance down. Isn't it true that I'm going to go to the next page because this is getting crowded. What I'm saying is this. I don't know the distance up. I don't know the distance down. I know they're the same, but I don't know what they are. I don't know the time up. I don't know the time down. But don't I have a very specific relation between the time up and the distance up? Like, don't I know that the time up, since the distance up and the distance down are the same? Let me put it this way. He's going slower on the way up. He's going slower on the way up than he's going on the way down. So which time, so is it going to take, I'm asking the class, like, please put, in fact, I'm going to literally say right now, because we have time. I'm going to ask you a couple of questions right now. I'm going to ask you all to put answers in the direct chat, like go private, please, for a minute. So no shame, no gain, and I'm going to give you time. In the private chat, I'm going to ask you sort of like yes, no-ish kind of questions. So first of all, just raise your hand right now if you're paying attention at all. Like if you're with me, if you hear me right now, just like, right, cool, thank you, awesome. And if you're like, oh, and she just put on a video, awesome, awesome. Okay, great, great. Thank you all. Okay, so I'm going to ask a couple questions and I'm going to ask you for the sake of one another, don't go in the public chat because it'll like mess with people's heads. Just in the private chat, just give me answers to these questions. And I want an answer from every single one of you, even if you want to put, and I won't, I'm just going to like read them and I'll like talk out loud. I'm not necessarily going to sit here and respond to every single one of them, but even in the private chat, even if you put, I don't know, or I am lost, or could you repeat the question? Or even if you put, honestly, I wasn't paying attention. It's fine. I'm not going to shame you, but I want input from everybody just so I know where I'm at. Okay. So here is, and if you say I wasn't paying attention, I'll hear that, then start paying attention, obviously, but I won't make fun of you or whatever. Okay. But I just do want everybody to pay attention now. So here you go. Here's my first question. If he's going slower on the way up than he is on the way down, then is he going to take more time on the way up or less time on the way up or the same amount of time on the way up as down? Like, I'll repeat the question again. We know for a fact he's going 40 miles an hour on the way up. We know for a fact he's going 60 miles an hour on the way down. Like, i.e., we know for a fact he's going slow up and then he's going fast down. So my question is, like, here's my question. Compare, and if you already heard it, yeah, put it in the chat. Thank you. Compare time up to time down. I want to know in the chat, do you think time up is going to be bigger or smaller or the same as time down? I'm looking and I'm going to wait till I get from everybody. And it's all in the direct chat, please. Yes, good. Awesome. Awesome. Okay. Awesome. Awesome. I see things in the chat. Awesome. Awesome. Oh, you guys are great. Awesome. Okay. And I'm even going to adjust slightly. I've now heard from just about all of you. Great. And almost awesome. And I'm just going to ask for one little correction, or just, I think I just heard from everybody. That's great. And almost everybody said the same thing. Just one thing I'm asking is the time up bigger or smaller? Like, don't say slower or faster because that's kind of ambiguous. Like, if you say slower or faster, that doesn't really answer the question. We know he's going slower up. But what I want to know is therefore the amount of time, like the number of minutes up, will it be bigger or smaller than the number of minutes down? And I think okay, I think I've just about heard from all of you. Okay, awesome. I'm not going to spend the time of responding in the chat, but I'm seeing it. It's great. And I'm checking, did I see from all of you? I think I saw from all of you. Just about. Okay, so let me start by saying I agree with most of you. If he's going slower on the way up, he's going to take more time to go on the way up. That seems reason. I think that's right. If you don't like that, put it in the chat. But I think if you just like if you said something else, but now you realize like, oh, I misinterpreted the question, whatever, fine. But I do agree with everybody who's saying it's going to take more time on the way up than that. Now I'm going to go a step further. Watch this. Watch this. Let's say we knew he was going 40 miles on 40 miles per hour on the way up, and he was going 80 miles per hour on the way down. In other words, let's say we knew for a fact that he was going twice as fast on the way down as he was on the way up. Then how would the times compare? Like, would the time up be 1/2 the amount of time on the way back down? Would the time up be twice as much as the way back down? Would it be equal? Would it be 1/3? I'll repeat the facts again. Say we know, so I'm changing the facts slightly here from the, say we know he's going 40 on the way up, but let's say, for example, that we know he's going 80 on the way down. So in other words, let's say we knew he's going twice as fast on the way down. How would the times compare? Then what could you say about the times? I'm asking in the chat, and please put in the direct chat, or put you need me to repeat the question or whatever. I can repeat the question. Okay, good. I'm getting answers. I'm seeing answers. Almost every answer I'm seeing is either completely correct or is like not complete, but almost correct. So
Can you repeat the question?
yeah. So I'm going to repeat the question. So my question is, and you may want to write this down, remember, and I'm changing the numbers of our original question to make them easier to picture. Let's say he goes up at 40 miles an hour. Okay, that is true in our question. He goes up at 40 miles per hour. But let's say instead of coming down at 60, let's say he comes down at 80. I'm on purpose saying, let's imagine he goes up at 40 and he comes down at 80. Then my question is, how would the times compare for up and down? Like, for example, could we say that he would take twice as much time to come down as he goes to go up? Or could we say he takes twice as much time to go up as he does to go down? Or could we say 4 times as much? Or so, can we say how the times would compare if we knew how the average speeds compared? And in your answers in the direct type, and I see that there's more answers now, be specific. Like, I want to know 2 things. I want you to tell me whether uptime or downtime would be bigger. And I want you to tell me by how much. Like, would it be twice as big or 3 times as big or 1/2 as big or whatever? That's what I'm looking. Oh my God. Okay, wait. That's what I'm looking for in the chat. So, okay, I see a lot in the chat. Okay, I see a lot in the chat, which is great. And I'm going to take that very happily and say, yes. I'm not going to wait till I get everything, but I see a lot in the chat. And I think you're all saying the same thing in the chat. You're all saying that if he were going twice as fast on the way down, we would know he was going, we would know that he took twice as much time to go up. Like, that's what most of you are telling me. And I agree with that, right? In other words, they're inversely proportionate, right? If he's going slower on the way up, he takes more time on the way up. If he's going literally twice as slow on the way up, he would literally take twice as much time. Not because everything in physics is always that straightforward, but because our equation here is a linear equation. When we say displacement equals average velocity times time, what we're literally saying, it's like a y equals mx plus b situation where b is 0. We're literally saying they're directly proportional to each other. So if the time, if the velocity is halved, then the time is doubled. Like, I agree with you guys. Now, so why am I doing this? Because it seems to me that's what it seems to me. Look, the time up is inversely proportional to the velocity up. The time down is inversely proportional to the velocity down, or the speed down. That's what you guys just told me, and that's what this abstract math seems to say. But that's what it's saying. In other words, in our actual numbers of this problem, if he was going up at 40 and in fact coming down at 60, that means he's not going to take twice as much time to go up, but it does mean he's going to take 3/2 as much time to go up, right? That's a harder fraction, but it's exactly the same concept. He's not going to take twice as much time to go up as to come down, but he's going to take 1.5 times as much, because 60 is 1.5 times 40. Just bear with. Now, that doesn't answer the whole question. But that's just a translation of what these little equations that I just made up mean. They're not formulas. They're not GDPs. They're not to be memorized. They don't apply to any other problem, really. They're step 4. They're just me doing my work in this problem, figuring something out that applies to this problem. Now I'm going to plug in numbers, right? I'm going to say, but this is how we do physics. Like, now I'm going to plug in numbers. I'm going to say, in other words, i.e., I'm still on step 4 here. This is, and we will finish this before I am watching the clock, I promise. Step 4, PAW continued, where I'm saying time up will be the distance up divided by 40 miles per hour. Time down will be the distance down divided by 60 miles per hour, right? Like that seems like that's the logic of what we just all agreed in the chat. But now I could do better than that, because remember, X up and X down are the same. So what I'm really saying now is, so let's call them both X. X up is the same as X down. Let's call them, let's call them both just X. Like, why do we have to call them X? Like the times are different up and down, but the distances are the same. So I'm just going to call the distance X, or if you don't like that, if that confuses you from other, you can call it D, whatever. But I'm saying now time up, sorry. And so X is the distance of up and it's the distance for down. Therefore, the total round trip distance X, right? In other words, equals X plus X, which is 2X, right? The total distance this guy's going to go. I still don't know what it is. I'm not pretending I know what it is. I don't know. I'm just calling it 2X. But the total distance this guy's going to go is 2X. In the total time this guy's going to travel, the total time apparently is X over 40 plus, well, the total time, let me be a bit slower about this. The total time is time up plus time down. It's not 2T. They're not the same T's. There's a time up and a time down. They're different, but we know what they are. In other words, the total time equals X over 40 plus X over 60. We are almost done, I promise. I might have lost some of you already. Some of you are just losing to boredom. Some of you I might lose to confusion. But let me tell you where we are. Why am I doing all this stuff? Because average speed equals distance over time. Average speed equals distance over time. That's all we know. That's all we can use. We might have been thinking, but we don't know the distance. So forget it. Like all hope is lost. But that doesn't mean we can't figure out things about the distance. It doesn't mean that we can't express the distance in terms that are workable. In other words, what I'm saying now, to bring this full circle, and we're just about done, I'm saying I actually now believe that even though there's a lot of things I don't know here, it seems like I don't know the distance up, I don't know the time up, I don't know the time down, I don't know, but they're all related. And I just related them all in a very tight way. So now I can literally say, I can go back. I keep doing that because these are the pages from the other class. Sorry. I can go back and say, thus, this is still all step 4. Thus, if the absolute value of average speed equals the round trip total distance over the total round trip time, right? That's my GDP, total distance over total time. If that's what I need, but that's what I think I don't have, I would argue now I do have it. The round trip distance is simply 2X, and the round trip time is X over 40 plus X over 60, right? That's what I'm saying. I'm expressing everything in terms of X. Everything boils down, everything is based on X. What is X? That unknown distance that I thought was really going to give me trouble. That unknown distance, the one thing I didn't know, in effect, I've called X. I've labeled it, as x, so that now in effect I have a name. It's called x, and I'm doing all my math around that x. I'm not giving up. I'm just doing, and I'm not ignoring it, or I'm not making up new things. I'm doing the physics and the math based on the one unknown thing that I don't know, and I'm calling it x. And by doing it all around that x, I now have this fraction, 2x over x divided by 40 plus x divided by 60. Well, hopefully many of you see where I'm going with this. I have x, I can factor out, to make this as clear as I can. I can factor out an x from the top, right? I can factor out an x from the bottom. So I now have an x in the top. I have an x in the bottom. I think most of you know now, like whatever number that is, it's like the top is being multiplied by whatever that number x is, the bottom is, so they cancel out, right? I mean, x divided by x, whatever x is 1, right? So by actually giving it a label, I'm finding out, I'm working through it, or I'm working around it. I'm finding out that x doesn't even matter at all. It's canceling out. And I'm going to get an answer, of course, but this is a big deal. X cancels. Which is very exciting, because now I can get an answer. It's very exciting that x cancels, that I did this carefully in a way that set things up so that x cancels. I'm happy, I'm excited, but also if I really think about it, and once I start getting more and more used to physics, I realize actually this shouldn't be a surprise at all. There had to be a way that I could set things up so that x would cancel, because unless the problem was a mistake, if the problem was a legitimate problem, if it was actually solvable, the fact that they never told me how big the hill was, but yet they still expected me to get an answer, actually must mean that the answer doesn't depend on how big the hill is, right? That's really what the question means. It's not that the question forgot to tell me the distance. It's telling me that somehow, no matter how big this hill is, somehow there is an average of these speeds that actually is correct. And all of us who said 50, even though I'm saying 50 is wrong, you're going to see in a minute, we don't get 50. And 50 is wrong. But anybody who thought 50, in their brain, tacitly, like in the back of their mind, they were thinking the same thing I'm saying here. They were thinking, I guess it doesn't matter how big the hill is. I'm just going to take 40 and 60 and average them. Like the answer just has to do with the speeds. It doesn't have to do with the distance, right? In other words, they got thrown off, whoever we are, we got thrown off enough by the lack of distance that we made up something. But somewhere in our brain, we allowed ourselves to make up something, because somewhere in our brain we knew, well, if he didn't tell us the distance, then I guess the distance just doesn't affect the answer. So I believe the answer is 50, regardless of what the distance is. With that part, I'm agreeing. I don't think the distance matters. I've set up a way to show myself that the distance doesn't have to matter, because both the speeds and the times are related to it. So the distance canceled out. And at the end of the day, and I am watching the clock, at the end of the day, I keep making that mistake. At the end of the day, speed, if you like, is whatever we just said, is 2 over 1 over 40 plus 1 over 60. Now, that's like not the, how do you do that? It's like sort of annoying, it goes back to 5th grade math or something like that. There's different ways to like add fractions in the denominators and stuff. What I'm going to do is get like a common, least common denominator or greatest common factor. In other words, I'm going to go like this. I'm going to go, you could do whatever way works for you, but I'm going to say, okay, what that really is 3 over 120 plus 2 over 120. You know what I'm saying? Like I multiply this by 3 over 3. I can do that, right? Because 3 over 3 is 1. So I'm allowed to do that. And I multiplied this one by 2 over 2. I'm allowed to do that because that's the same thing as 1, right? So I just did that so I can get a common denominator. Or you could do it by 240. If you're more comfortable with that, it's fine, whatever works. But so now I say that's 2 over 3. Sorry. That's 2 over the smaller fraction, 5 over 120. Well, that still seems annoying. It's like a fraction over a fraction. But what is that? How do you divide by fractions? You multiply by their reciprocal, right? In other words, it's 2 times 120 over 5, right? That's what this is. So in other words, it's 240 divided by 5. We are just about done, and we're just about done. I say for my final step, for step 5, final answer circled, it seems to me that the average, like the divided by 5, right? Yeah. 240 divided by 5, which is to say 48. That's my answer. Wait, oh my God. Sorry. First of all, wait, hold on one second. I'm so sorry. Hold on. Felix, I will be up in a second. You can't keep screaming. My class is over 2 minutes. I'll be up in a minute. Are you okay? Wait, Felix, please don't scream. Okay, I'll be up in 2 minutes. You can't scream desperately for a piece of pizza. I'll be up in 2 minutes. I'm teaching. Okay, first of all, if nothing else, that's the answer. The answer is 48. But I want to say, but I have 2 more minutes. I want to use them. Because that seems like a lot, right? I mean, that is a harder problem than it looks like. Now, there are, in fact, in a way, easier ways to do that. I'm going to mention in a second. There are, but that's the most like fair. Like there's faster ways to do it, but you have to see them in your head, and some of them would seem unfair to some people. To me, to my mind, that's the most fair, legitimate, like step-by-step way to do it. That's number one. But number two, notice the answer is 48. Like what? Why is the answer 48? Why isn't it 50? Because and I want you to see average speed really means the one number that would represent the whole. You might be thinking, well, then this is like not an average. Why do you get 48? Like it doesn't, I guess physicists use average, the word, in a different way. No. We are using it in the same way. The reason we get 48, not 50, think about this, is because he spent some time going 40 miles per hour, but then he spent a lot less time going 60 miles per hour, right? Time is the independent variable here. This isn't as though you got a 40 on an exam and then a 60 on an exam. This is really as though you got a 40. It's like you took 5 exams and you got a 40, a 40, a 40, and then a 60, and then a 60. In other words, remember, you guys told me in the chat, he's spending 3/2 as much time going at the slower speed than he is going the faster speed. So if you're really doing a real average, if you're really averaging them, what's not fair is just to give the 40 and the 60 equal weight. That's the mistake in just putting them together like that. What's really happening is he's doing 40 for like 3/5 of the time, and he's doing 60 for like 2/5 of the time. So on average, at the end of the day, he's going a little at a speed that's a little bit closer to 40 than it is to 60. It's a little bit slower than 50. It's 48. It actually really makes sense when you really think about it. But you have to think about it according to only our definitions and not make up new definitions. And you'll ultimately see that our definitions do match whatever else is thinking in your brain. But there's the bottom line is it's a weighted average. He did not spend an equal amount of time going 40 or 60. We'll end there. But you've been very patient. Hopefully that's clear. I'm going to look in the chat, and if there's questions on it, I'm going to turn off the recording. But awesome, good job, and I hope it's clear. And I apologize for my son. Well, I apologize for my bad parenting. Okay, have a good weekend. I'm turning off the recording. Thank you. Have a good weekend. And watch the other video, please. Where is the recording? Where?